Okay, so let's finish off example 19D, which says state the values of x where the function is increasing and decreasing. If we look at our graph, our function is increasing at the places where the tangent is positive. So we drew tangents to every point on our graph. We can see that right now it's pointing upwards up until we reach that flat stationary point. So in that case, it's increasing from negative infinity up to that -5 point. And then it's decreasing, the tangents are going downwards until we reach that next stationary point. So from -5 to 1, we have decreasing function, and then our function then increases, our tangents are positive again up to positive infinity. So for part D, we can say that function is increasing if our derivative y dash is positive, and we have that function is decreasing if our function gradient y dash is negative. So therefore, from the graph, we can see that y, because I called the function y, from graph function is increasing when x is between negative infinity to that -5 point. Take note that it is not inclusive of -5, because at the point of -5, the tangent is 0, so it's not increasing or decreasing. So it's non-inclusive of the stationary points, and it's also increasing to the right of 1, so from 1 to positive infinity. If you don't like the inequality notation, you could also write that in bracket notation, and you would use round brackets to indicate non-inclusive. Again, it's not including the two stationary points of -5 and 1, because at the stationary point itself, the gradient of the tangent is 0. It's not increasing, it's not positive or negative. It's increasing at those two sections, and then we know that it is, so function is decreasing when it's between -5 and 1, again not inclusive. If you prefer the bracket notation, it will just be round bracket -5 1, because it's not inclusive.